All right, everybody. Good morning. I know this is Saturday morning, so some of you may not be able to make it. But I know that you can all watch this video. So I will just go ahead and start recording for our meeting today. And whenever you go over it and you find some questions, you are free to um, post a question on the discussion post or send me a message. Okay, I'm going to share my screen with you now. Okay, so what we are going to cover today is probability distribution. According to the module for this week, we are to cover the module 4 lecture notes, which are about the probability distribution of random variables. And I would say that they include mainly the discrete random variables. Discrete random variables, I will use the PowerPoint to go over it for our lecture. Okay. Discrete random variables include, it means those variables that only take on discrete values, which are not continuous. Usually these numbers are what? Integers, positive integers, including 0. For example, the tossing of coin of the number tossing, if you're tossing a coin n times, and each time you want to know the number of heads out of n such experiments, then you you can expect the number of heads to be 0 or 1 or 2 all the way up to n heads. So this is a typical example for the discrete random variable. Actually, because the coin is also usually a fair coin of 50-50% head or tail. So this kind of experiment is a typical example to illustrate the binomial distribution. Okay, and binomial distribution is most popular distribution in discrete probability distribution. Okay, we talked about that and in detail. And also another distribution is called Poisson probability distribution. Okay, it's kind of similar to binomial distribution, except that it's n goes to infinity. In other words, n is infinitely large. Okay, so each time you just need to know its parameter called lambda, and then you will be able to calculate according to the formula what is a specific probability you're given a number of x, which follows the Poisson distribution. Okay, these two random variables are the two most commonly used random variables that we want to look at. Okay, also for the sake of time as well. Okay, now, but first we also need to see what is probability distribution and probability histogram. Okay. Probability distribution is the listing of the possible values and corresponding probabilities of the discrete random variable, or a formula for the probabilities. It can be displayed in graphical form, and it becomes what? Probability histogram. If you display the probability distribution in terms of graphical form, it will be a histogram. And histogram is the most popular way of describing the distribution of your random variable, discrete random variable. Okay, in this case. Okay. So also you can display it in the tabular form, like this one. Tabular form, you have numbers. All these, as you can see, are integers and including 0. And each value has its corresponding probability. All the sum of the probability must be equal to 1 to qualify it to be a probability distribution. Okay. Oh, hi, Helena, welcome.
Good morning.
Good morning. Good morning. Sorry to pick on the morning time, but I know I started recording and I go on for a little bit, so you can just go back and review it. Okay. Okay. Hello. Yeah. Hello. Okay. Yeah. Hope that I already started recording, and right. So for the previous recording, you just go back to watch the recording, but it's not a quite a big deal. I will, as we go, you will understand the rest of it. Okay. We talked about probability distribution, and that include charts or tables and so forth. If it's in a graphical form, it will be called histogram. Okay. Yeah. The height corresponds to the value on the second column on the probability. Okay. So that's a way to display is the distribution. And the sum of the probability column must be equal to 1, right? Here's an interpretation of probability distribution. In a large number of independent observations of a random variable x, the proportion of times each possible value occurs will approximate the probability distribution of x. Or equivalently, the proportion histogram will approximate the probability histogram for x. The proportion of time each possible value occur will approximate the probability distribution. This is, well, proportion basically conveys the same concept as probability. Probability is proportion in its strictest sense. So we can understand that they are equivalent. Okay. All right. Actually, we use them interchangeably down the road. All right. Here let's see mean and standard deviation of a discrete random variable. What is discrete random variable? We talked about that a while ago, which is values that take on usually integer numbers, may include 0 or not. Okay, the examples I pointed out, I use include the number of heads out of n tossing of a fair coin. Okay, or if you, yeah, that's the best example. All right, and now how do we that being said, how do you calculate the mean of a discrete random variable? That the way to calculate is to calculate it through the products of the value and and its probability. You get the, we call it expected value, which is a mean, or mean is expected value of that discrete random variable x. So in order to calculate the x, what do we do? For example, in this example, you have value and the probability, and so forth. So how do you calculate the mean, which is expected value? It's just the product of is assuming this is Excel. So you create the third column, which you call x times p, x equal to x, x times p, x equal to x. Then 0 times that, 1 times this, 2 times that, and then sum up this column will get mean, all right? We will have an example to calculate that. Let's skip this one. And standard deviation, how do you calculate standard deviation? Remember, these two formulas are equivalent. You can derive through the, you can prove that these two are equal. And the reason for the second one is that this one is easier in its calculation, but their result is the same, all right? They are the same. That can be proved on, but we don't do the proof here. All right, so what you can do is, excuse me, if you go back to the previous, this one, then what you can do is, after you calculate mean, mu, you create the fourth column in Excel, x squared, then 0, 1, 4, 9, 16. Then what? And you multiply probability by x squared, you get a fifth column, okay? The third column is a product of x and its probability. The fourth column is x squared. The fifth column is what? X squared times its probability. Okay, x squared times its probability, so on and so forth. Then you take the sum of that x squared with this probability column, then subtract. And oh well, not yet. You need to create. Yes, subtract. There are 1, 2, 3, 4, 5. 5. There are five values of x here. So subtract 5 times u squared. So it will be this. It will be this. Okay. Let me see this. Yeah. Okay. So we will have an example showing how to work this out using Excel. No worries. Okay. All right. Then binomial distribution. What is binomial distribution? The distribution that follows meet these criteria. Okay, so repeated trials of an experiment are called Bernoulli trials. Okay, first, what is a Bernoulli trial? Bernoulli trial is the special form of binomial trial. Binomial trial, when you have multiple Bernoulli trials, it becomes binomial. Okay, so one Bernoulli trial is it's like you toss a coin one time, and then you have two outcomes. S success, F for failure. So you denote head as success, tail as failure, and it becomes a coin tossing experiment. And the trials are independent, means the outcome of on the one trial is no different, no way affect the outcome of other trial. For example, like if you toss a coin and then get 3 heads in a row, it won't increase or decrease the probability of getting a tail in the 4th toss, which is 50%. And so this is Bernoulli. You can consider it as tossing a coin one time, or binomial distribution with n equals to 1. But when you have multiple Bernoulli events, let's say n Bernoulli events combined together, that will become binomial trial. We also call binomial random variable. Okay. All right. So, and this is how the probability is calculated and so forth. So we won't get into these details. Okay, and this is based on this example. You can derive a formula for binomial random variables. This is n choose x times px to the x times 1 minus p to the n minus x power. Okay, so you can plug in any number of n, and then you change number of x, given a p-value, you will be able to calculate the probability of for example, if n is 10 and you want to know what's the probability that I get 9 heads in a row, or 9 heads out of 10 tosses. So you plug in 10, choose 9, and if there's a fair coin, p equal to 0.5, 0.5 to the 5 power times 0.5 to the 5th power. So this is the way to calculate the probability. We will also show you a very useful software called StatDisk, which you may use to calculate this very, very easily without even have to go through these formulas. Okay, but these formulas are here, so you know that they are not magic, not something come out of nowhere. It's based on the formula that the software used to generate the results. Okay. And here you can see that as a p is smaller, it's a little bit skewed to the right. If p is 0.5, then the probability of it's symmetric. Probability for heads, the probability of tails, they have equal numbers. Okay, when the p is greater, that means the probability of head is greater. That means the coin is biased. Then what? Then the probability of getting more heads, right? 4, 5, 6, 7 heads are higher. It's n equal to 6. Then the number of more heads is higher. If p is smaller, then probability of the less number of heads are higher. If p is 0.5, then probability of getting equal numbers of heads or tails are highest. Okay, which is 3. 3 heads or 3 tails. This probability is highest. Okay. And this is a formula for calculating the mean by times n times p, and sigma equals the square root of n times p times q. Okay. These formulas can be derived by plugging in this formula into this formula. how do I get the square root MPQ as the standard deviation for binomial distribution? I plug that P formula into here, then I can derive that formula. Okay, so these are not some formula that you have to memorize. Of course, this would be good if you could, but it won't make sense unless you realize how it comes about. Okay, so I don't require you to memorize. Instead, I will give you the the software you need for calculation of it. Okay. All right. Then I can skip this. Then Poisson probability distribution. Poisson is what? Poisson probability distribution looks like this, where E is exponential function equal to approximate to 2.71. Actually, it's an infinite series like pi. Okay, so it goes on to infinity, and it has lambda as power negative, and so this is a formula. The way it comes about, you can don't have time to explain it, but use exponential function and do a little bit reorganizing. You will see this formula. Okay. Okay, as I mentioned, as every number of x has a probability associated with it, normally it should go on to infinity, but because the probability is already very small after you hit the number 18, so 18 and higher is almost zero. Doesn't mean it's exactly zero, it's almost zero. Okay, if you extend the decimal places, you will see it go on to forever. Okay. All right. Okay. So, and this is the distribution. Okay. And this is a formula for its mean equal to lambda and sigma equal to square root lambda. Again, how do I know these two values? I plug this number into the sigma formula in slide. In here, okay, in the 14th page slide. Okay, then I get this here, right here. Okay, the derivation is not necessary. The proof is not important. You just get the result, and you don't even have to memorize the result because the statistical will do it for you, or Excel can calculate it for you. All right. Okay. So I think this is good for it. I will bring to you now. We'll cover the assignments. Okay. Let me see. I'll cover the assignments over here. Okay. Let's go over the assignments, but before we go over it, I want you to create an account or download, which is free, StatDisk. Okay, StatDisk. Let me StatDisk. Okay, I send it to you in the chat. Open it and you will see what I see in my screen, where you can open an online account, which is free, okay, or download it. I have one in my computer, so I open it, and you should be able to see it now. Then I click on analysis. I will see the probability distribution. So here you will see what binomial and Poisson. Once you click on binomial, you will see a table like this with number of trial n and the success probability 0.1. Okay, and as mentioned is consider this example of tossing coin 10 times. Suppose we are tossing coin 10 times, and you have the suppose it's an unbiased coin, the 0.5 probability for head and tails equally. Then you just plug them in here, then click on evaluate, and it does everything for you, including using the formula shown in the slides to calculate the mean and the standard deviation. So you have mean and standard deviation and variance all calculated at one click for you very quickly. And these tables give you everything you need: point probability, cumulative probability, and cumulative probability from the reverse direction. Okay, so for example, what is the probability x equal to 7? That's 0.1171875. And what is the probability that x less than or equal to 7 is that? What's the probability that x is greater than or equal to 7? 0.1718. And you can, yeah. So you have this table available. Okay, so now let's come to this question 1. We'll quickly go over them. The first question is to calculate the probability given a table. So what's the probability x greater than or equal to 6? Okay, so what you need to do is greater than or equal to, then include the 6 and higher, 6 to 12. So what you need to do is just to sum up these numbers. The numbers under the column, under the column of probability, but corresponding to the value of 6 and higher. Okay, what you should do is just to copy, open it in Excel, and select the sum for these numbers from 0.03, 0.003 all the way to 0.069. You will get the probability. So on and so forth. This is not a big deal. So if it asks you x equal to 8, p x equal to 8, then there's a probability of x equal to 8, 0.133. Okay. Of course, you can also easily convert this into a histogram. No problem. All right, so this is easy. Don't hesitate to let me know whenever you have questions. Now here we have T and Z. Of course, this is supposed to be in the section for continuous probability, but it brings about here just so that you have some basic concept of a probability, okay, established. Also here, as you can see, you can draw a graph of like a T as similar to bell shape of Z, but it's a little bit heavier in the two tails. Okay, so for T greater than 2.34 is 0.07, T less than negative 2.34 is 0.07. So what is the remaining area left? In other words, consider this picture. You have a bell-shaped curve in the middle, but you truncate the two tails, and the two tails each equals to 0.07, and you have two of them. So you have to cut the two tails from the bell shape, which is with area equal to 1. So that's a way to calculate this area in this probability, which is areas under the curve that equal to 1 minus 0.07 minus 0.07. Then you also have z between negative 1.64 and 1.64. So now that you know the area in the middle, right, which is 0.9, but the two-tail is what? Equal. So, and the whole thing is what? 1. 1 minus 0.9 is the two-tail, and then you divide the two-tail by 2 will be the answer. Okay, so if you, in other words, let me draw a, yeah, we still have 10 minutes. Yeah, I think this one is easy. Let's go move on. If we have time, come back and draw a graph. Okay, this is another graph, and now using it to calculate mu. So how do you do it? Then you just use a formula, which is what? X times, let me open it in Excel for you. Okay, and you do the product of the X with its probability, and then take the sum of all the products. Here you have 8, 7. You have 1, 2. Okay, then you create a column called, yeah, you should be able to see my Excel file. And you create a column called XP, X equal to X, and equal to this times that, right? Then you add them, right? I won't do everything same for you. And then take the sum, right? Sum of this column, right? It will be your mu. I suppose that's your mu. Of course, I delete one row, so okay. And then that's a mu. What about let's see. I won't plug in the answer, but let's view an example so I don't have to plug in the answer. So this is a formula. What I just did is actually using the formula. And then based on the formula, you are to, then you interpret the mean. What does that mean? Okay, you can do it. And now to calculate sigma, you have to use this formula. But there's another equivalent form of that formula, which is sigma equal to that. So what should you do? You should do as I have mentioned, that you need to calculate, create a column and then multiply by its probability. So create a column x squared, and this column is equal to a squared. Let me make it bigger. A squared, and so on and so forth. You drag the corner, sorry. 1 second. It's not. Okay. It's that, and you drag it. Okay, to make it copy. So you can see 2 squared is 4, 3 squared is 9, and so forth. And then x squared times px equal to x. It will be what? This times that. And then you make copies. It should work. Yeah. Yeah. Okay. And so that's a column, and then what should you do then? You sum it up. but then minus subtract the square of mu square. Okay, you take the sum of these guys of all these guys. Sorry. My cursor is not very good. Okay, 2, 2, 7. Okay, and then minus mu square. So equal to this guy minus mu square. But take the square root, SQRT, parenthesis. This is your sigma. Okay, based on the formula. Okay, of course you can do it using the original form of the sigma formula. You will get the same result. Okay. All right. Okay. Any questions so far? Okay. Let me know whenever you got questions. So this is a way to do it. And this one is the same. You multiply the product of 0 and its probability 1 and with its probability 2, which is probability, and take the sum of them. You get mu. And then use the formula, do similar things. You only change the value and its probability, you will get the answers. Okay. And now then this is okay, then we look at the lambda Poisson probability distribution, lambda equal to 4.9. Okay, lambda equal to 4.9, you can use a stat disk to calculate. Instead of you plugging the formulas, you can use stat disk. It's under analysis, probability distributions. You click on Poisson distribution. Okay, then you plug in lambda. What's the lambda value here? It's 4.9. 4.9. So 4.9. Evaluate. Look, it gives you everything. Give you a lambda, which is equal to this mu, according to the slide I've shown you. And its standard deviation, the square root of square root of 4.9. Yeah, you get 2.21 as its standard deviation. Otherwise, its lambda should be equal to sigma square, which is variance. Then you have everything as you saw in binomial distribution, where you have point probability, cumulative probability, and cumulative probability from the other direction. Okay, so and you can plot, and this is how it looks like. Don't know why. Okay, yeah. Okay, so you can see the distribution looks like this. Okay, and all right, so very handy, very convenient. So now with this, you can, okay, what's the probability x equal to 7? X equal to 7, that is, oh, not this one. Let's go back. Poisson. Suppose lambda is 10, okay, and then its probability 7 is here, right here, this one. But you have to just plug in the 4.9, you will get it, okay? And so on and so forth, the other numbers less than 4. Less than 4 doesn't include 4. So less than 4 doesn't include, that means start with 3. So less than or equal to 4, that means less than 4 means less than or equal to 3. So but that's cumulative. So it's 3 or less. So this is the answer, 0.013034. So on and so forth. All right. Now, in study of ends, this one, I'll leave this one to you. It's more descriptive. Okay. Suppose 26 of birth in a certain region take place by C-section each year. That means the probability of C-section is about a quarter, about 0.26. In a sample of 500 births, how many on average take place by C-sections? Okay, so 500 births in average, that's a mean. So what do you do? Calculate the mean, but how do you know the mean? By the formula. This is a binomial probability distribution, like a toss a coin 500 times, and each time the probability of success or head. If they do a C-section and we define that as a success, define that as a head, and then the probability of that success is 0.26. So n is 10. N is p is 0.26 and n is 500. So you just use stat disk and use probability binomial distribution 500 and 0.26. Okay, and that will give you the answer. Let me change it to 100 and 0.3, and you will see that its mean average, its mean is 30. Okay, how do I get that? 100 times 0.3 is 30. The formula you saw in the slide. Okay, so the same thing, you will get it. And then the standard deviation right here is calculated. Standard deviation is calculated. Okay, and so forth. Okay, then you get it. Okay, and answer to from interval that's likely contain birth the same. What use the answer to part A and B to form an interval that's likely to contain the number of C-section births in the sample 500. What does that? Let me take an example. Yeah, we did everything correctly. 26. Okay, is binomial distribution for large n is approximately mount shape or symmetric. That's also in the slide. We just didn't cover it very detailedly. It's just that as n become large, it approximate binomial distribution. Okay, and so the value you can follow this this to calculate the interval. Now that you have mu and you have sigma, you can calculate lower bound by doing mu minus 2 sigma and upper bound mu plus 2 sigma. Okay. Part B from any likely to contain the number of C-section births in the 500s. Form an interval that's likely to contain the number of C-section births in the sample 500s. This question is not very clear to me, but you can just give it a try and see if you get these numbers. 95% likely to be in the interval. So yeah, follow this, because I don't see this question is clearly stated. Okay, it's not very clearly stated. Okay, anyway, you just do 9, because data we'll see next week that 95% will be contained in this interval according to the empirical rule. Empirical rule is a continuous probability distribution, which we won't see until next week. But not a problem. You can just do it accordingly in this way. Calculate mu, calculate sigma, and then what? Calculate the upper bound and lower bound, and that will include 95% of the birth, okay, which is by C-section, okay. Okay, last question. That's also Poisson, so you know how to do it. Just plug in 5 using Poisson and plug in lambda equal to 5. You will see everything, and the plot the graph. Well, you will see the plot. Okay, and then compare it with that. I think so. This question should be self-explanatory, and I'll leave it to you. Okay, it's good. I think it's good to stop here. Let's see if you have any questions. Okay, any questions?
No questions.
Okay. Very good. Do you, give it a try to install the StatDis. As you can see, it's very handy. Or you can use Excel, but in this case, StatDis will do a quicker job than Excel for you. Okay, all right, good. So let's call it an end here, and I hope you. Yeah, it's a very early start. We won't start week 4 until next Monday, but
okay.
Since Monday is a big holiday, so I think it's good to do it on Saturday. Okay, and I hope you have a good. I hope you have a good, very good day, and enjoy your long weekend. Okay.
You too. Thank you.
All right.
Bye.
Okay. Bye.